So far, what we have done is we have worked on what is called combinational logic. And combinational logic has been, if we really view it down into the different pieces that we've done, we started off by looking at Boolean logic. From Boolean logic, we moved to form up K-maps. K-maps give us gates of what we're trying to solve, whether it be and, or, not, XOR, the NAND, the NOR. There was a number of different ways where we can implement the logic that we were trying to achieve. Then we moved to larger building blocks, such as looking at a mux, a decoder. So we did a number of those different items. But when we really brought it down to all combinational logic had was all of this information really came from a truth table, where I can manipulate everything to form up this truth table. Within this truth table, I had an input, and let's say that input was all zeros, 0, 0, 0. And I was looking at forming up an output. And that output, for example, might have been 1. And in this setup right here, another item we can say is what's occurring with combinational logic is we did a map of 1 to 1, where we said one input combination has one output. And that's all that we're ever able to produce, which means at this point in time, all the information needs to be available at the time I process to determine what the output would need to be. Now, a lot of times, this is going to solve a large number of our problems. But at other times, it's going to be kind of lacking a little bit of information. And when it comes to lacking information, that's what's going to lead us into the next type of circuit we're going to discuss, which is called sequential logic. And now this sequential logic, what it's going to do is it's going to start to manipulate our setup, where I'm going to draw out sequential logic in a little diagram. And in this diagram, it's really going to show what the difference is. Okay, so the difference is going to be, we have some familiar pieces. The common pieces are, I have some input coming into the system, and I have some output that's leaving the system. Now, in order to produce anything, everything has to be set up over some type of logic that I want to create. Where that logic is, given this input, what is it that I want to produce? So we would have some combinational circuit being used. So a sequential logic is made up of having some combinational piece. This combinational piece, that's what's producing our output. We take in the input, we're using that input to kind of process what it is that we want, but there's going to be something extra added in. How do we get to the sequential piece? Is I'm adding in one extra element called memory. Now this memory, what we're going to do is I'm going to take a little bit of this output, or what's occurring in my combinational circuit, and I'm going to feed that back into my input. And this is a key item that comes up with sequential logic, which is called the feedback mechanism. Where this feedback mechanism is going to have a couple of different important contributions to a new type of circuit that we're going to create. What it's going to do, it's going to allow our logic to be processed in steps. Now, these steps, they could be called a lot of different items. It could be called, it's a step. It's another term we're going to refer to, it's a state. They kind of mean the same item. is that I want something to happen based off what has happened in the past and my current set of input. All right, so let me give you an example of what sequential logic might be kind of viewed as. All right, so let's say sequential logic is the following items. Let's look at turning on a light. Okay, so there's some light in a room. So, okay, so here we have a room. In that room, we have some light, some lamp on the ceiling is shining down some light to us. Okay, and we want to figure out how do we turn on this light? There's different methods that we can use to turn on this light. One method could be, on the wall, I have a light switch. Well, this light switch, we can say, I want this light switch right now. This is kind of like a combinational logic where it's simple. I can break it down into, I know what the switch is and what do I want with that light. If the switch is off, I want the light off. If the switch is on, I want the light on. It's an easy truth table. There's no memory, no feedback that I need to provide the system. The opposite way could be I have on the wall a switch, and this switch is a touch switch where there is no lever. It's just something that I physically tap, and the tapping of it turns it on. Think of it as the same setup of like your cell phone. There is no switch to show that you touch an icon on your cell phone. It just registers that you touch something. Well, this switch here now has to change a little bit. What we're really focused on is what is happening based off of a touch. Now, this touch works in a different setup. It's not as simple as saying 0, 0. Switch is off, light is off. Switch is on, light is on. The touch really has some type of steps where these steps are based off of past events. I want something new to occur. Okay, so let's take this room example and let's start forming it up as if I was to make a truth table. My output is still a light. Now my input is going to be based off of this touch and also off of, let's call it the current light value. What was this lamp currently doing? So if I have no touch and the current light was off, I expect that the light to be off. I touch it, the light was off. What do I expect to happen? I expect the light to turn on. Now that's just two of the current options. The other options could be you do not touch the light switch. The light is on. What do I expect to have happen? I expected the light to stay on. Now I touch the switch. The light was on. What do I expect to have happen? Is I expect this light to turn off. So what is this showing us? This is showing us a very simplified example of sequential logic. Where here in this little diagram, I have my light, that's the lamp, the light bulb on the ceiling of the room. I have my input, which is that little touch sensor that I've replaced the little physical light switch with. In here, I have my combinational piece. Now, this combinational piece, that's just a truth table. Which truth table is this? Well, that's simple. I'm just taking this little set of 4 options and I'm building that into that system. And then I'm adding in a memory element, where that memory element, that's the current value, which I'm using as part of the feedback, telling my combinational logic that truth table, how should it work? You could see that now this is going to be a little bit different. It's still going to have some type of AND gates, OR gates, NOT gates involved, but this little memory piece is going to start becoming important. It's going to change how it is that I want to create my circuit.